In this video, I'm going to be showing a motherboard repair of a mini PC. So the System X is my home lab and it runs really lightweight services and it's powered on 24/7. I have it connected to a battery backup and it's actually the second time it failed. And I was able to repair it the first time. So just in case I got lucky and was able to fix it the second time, I decided to document the process just in case it helps out somebody out there. Both times, turns out, it was just a shorted capacitor.
All right, so this is a BOSGAME P4 Pro mini PC. It came with 16 gigs of RAM and half a terabyte hard drive, which I replaced. And it's a 5000 series AMD CPU, so it's pretty quick. And it lasted for about a year, just over a year, just after warranty, when it had a capacitor go out on it. And after watching a lot of YouTube videos, I was able to troubleshoot it and figure out which one it was and was able to fix it. Also, when the capacitor went, it caused a lot of current to go through one of the power MOSFETs, and that fried the power MOSFET. But I was able to take one of the power MOSFETs from the USB-C port on the front here and use it as a replacement. So I lost a little bit of functionality. So I can't power it through the USB-C port in the front safely. But not a big deal. I just power from the 19 volts anyway. All right, should be all the screws. Yeah, it's coming off. And the fan, this lower fan's got a connector on it there. So this fan is to help cool the SSDs, and there's a single heat pad inside, and then there's this metal piece to act as a heat sink. All right, so it's got two SSDs and then the 16 gigs of RAM, 2 8 sticks. DDR4 in short supply right now. That's 512. And then this one is the main 2 terabyte drive, which has got the operating system on it and also a partition for my NAS. This thing is my whole server home lab setup. It's got absolutely everything on it. It does my NAS, my home video recorder, my automation for my kitchen light, so it turns on when I walk into the kitchen. And it's my router, DNS, it does everything. It's even, the router software allows this little Wi-Fi card here to act as a access point. So last time this quit working. Here's the DC jack here, the DCN. There are two MOSFETs here that the 19 volts passes through. The second one blew. And it blew because one of the capacitors that used to be here, I took the capacitor off. The capacitor was shorted and it caused that MOSFET to blow up. So I took off that capacitor and then I took one of the power MOSFETs from this USB-C port. There were two of them, one here, and then there was one here. I took this one and I put it here. Luckily, it was the exact same type. And I think this one in particular, is the one that allows the power to go in from the USB-C into this point here, and then this MOSFET stops the power from going to the rest of the motherboard unless it's signaled, to do so. So that's how you can have both the DC power in and the USB-C powered in at the same time. And then there's a chip on the motherboard. It might be this one, but I'm not sure. That will decide which one to activate. I can see the whole board. And I don't see anything. Nothing real evident is blown up. Okay, so let's see if the main power bus is shorted. I'll just pick a random one. Oh, it's 8 ohms. And whatever power rail it's on is shorted out. This might be one of the power, like the power for the CPU capacitors. And you don't want these to be shorted out, because that means there's a short. The 19 volts might have gone to the CPU, and if 19 volts goes to the CPU, it'll fry it. So those are not shorted out. So that's good. Good for being a bad situation. Similar symptoms to last time. All right, I need to, in order to identify what part has blown up on this thing or shorted out, I need to get a thermal camera. I had one briefly, but I didn't like it, so I returned it, and I just never got another one. So I need to order a thermal camera again and inject voltage and see if I can determine if something easy to replace is getting hot. Okay, thermal camera has arrived. And it is a Thermomaster, and it uses the phone that I'm recording this with, so we will see how that goes, but hopefully I'll be able to figure out what part is getting hot with this. All right, so since we know we do have a short, I need to take this out of the motherboard out of the case and inject power into it. So to do the voltage injection, I'm going to need another tool. So I've got a little USB-C power supply. It uses a USB-C power delivery as the actual power supply, and it just goes in here. All right, so here's my power adapter. So now we can inject voltage into the motherboard and see if we can spot something that's getting hot.
This is a video that the infrared camera captured, and you can see it's not a very high resolution, so it's really hard to make out detail. But I'm injecting 1 volt, and I used 3 amps to get it to show this kind of brightening area when I inject the voltage, and then it dims when I remove it. So that's the area that I'm going to first focus on.
What I think is the problem component, one of those 2 capacitors right here. So I'm going to desolder those next. Make sure that there's no bridging going on. There's that little tiny capacitor right next to it. And that one's still on. I just want to see if removing this bigger one removes the short. So let's see now if we still have a short. Yeah. All right, let's get rid of that real small one too. There we go. The other one is here. I wonder if I can measure that. Okay, let's see if we still have a short. Yeah, we still have a short. So those guys were not the problem. Okay, so let's go back to injecting voltage again, and we'll see if that area still gets hot or not. And we'll switch over to the thermal camera again.
So here I am doing that voltage injection again, 1 volt and 3 amps. And I saw the exact same warming that I did the first time. So I just couldn't quite tell where I was pointed at. I tried a different mode, like a different coloring mode that the software that the camera came with has got. And this other color maybe gave me more detail, but you can kind of just see it's very diffuse here. And it turns out it's because it's on the other side of the board.
Well, it doesn't look like that was the right thing to desolder, but it for sure is right underneath of where those capacitors are at. It's definitely not these capacitors next to it. So that's going to be something under here. I'll have to take off the heatsink to take a look. Maybe I'll try to measure one of that larger of the two capacitors I took off to see if it's okay. It will be really hard to measure because of how small it is. All right. Might be this area here. It's right there. There's this big electrolytic capacitor there, but there's also this, might be the MOSFET too. Okay, so I'm gonna get set up to inject power again.
All right, so I'm on the right side of the motherboard with the failed component now. You can almost kind of see what component it is, but there's really just not quite enough resolution, unfortunately.
All right, so it looked like it was this electrolytic capacitor getting hot, or that ceramic capacitor right there. So I don't think I'll be able to use the soldering iron to get that guy off. So I'll get out the hot air station next. So I got the hot air station out. All right, so we're gonna try to get this guy off, and I'll try to leave that other capacitor. All right, there we go. Now let's see if the short is gone. No, it's still there. Okay, let's see if we can get that capacitor right here off. There we go. Okay, let's see if the short is gone yet. So this is to ground. Hey, it looks good. Yep, the short is gone. So it was that little dinky thing? So this one from the other side that we first removed is okay. So I will put that guy back on and put the electrolytic capacitor back on. And then we can continue to see if one of the MOSFETs got shorted. So we will just not have a capacitor there, a ceramic capacitor there. We will just have this electrolytic there. Okay, so just to show this again, we've got this capacitor here, not shorted. This one, shorted. So I'm doing that trick where you put the screw in a little bit, you go backwards until you hear a click, and then you go forward, make sure you don't cross thread it. So now let's see how my MOSFETs up here are doing. This one seems okay. That one's still connected, so it's shorted. You know, it is possible that it's just currently got some voltage on the gate causing it to be connected still. So it's not a surefire way of measuring it. From what I understand, I think that's right. Okay, so what I'm going to do is take off the suspect one that's here. Okay, I decided I'm going to do what I did last time, and I'm going to take the MOSFET from the USB port over here and plop it right there. I'm hoping that the USB will still work with 5 volts, so it'll be, you know, I can plug a hard drive in it or a mouse or anything. Yeah, I won't be able to use the USB PD, which is how it is right now anyways. Okay, so I was studying the work that I had done, and I noticed that I bumped a component over here when I was removing my donor MOSFET. So I'm going to use this flathead screwdriver. There we go. I think I got it. It's so small. Okay, so this is the last capacitor that I need to do, and it's also the first capacitor I took off. It was a false positive. I'm just going to hold it in place so it doesn't blow away. Okay, that should be good. Now, the moment of truth. So this little mini PC has a light on the this power button. I think that's the power button. So if what I did solved the problem, that light should turn on when I plug this power in. Fingers crossed. Yes, we have a light. Let me do it one more time, just make sure. Yep. Okay. Haha, that's great. Wow. I can't believe that worked. Okay, so let's go ahead and put this guy all back together. I've got some pieces in here. And these little tiny connectors for the antenna for the radio. And then there's a little plastic piece. The best way to do this is to pre-populate these screws because they have to go way down. Okay, moment of truth. Man, it's a great PC. As far as the specifications are concerned, it's absolutely perfect. But I guess they have used the world's cheapest ceramic capacitors in this thing. Let's see what it does. It looks like it's, yep, it's back online. Holy cow. Just booted up my PC and gonna go, look at that. It's back online. Uptime, 3 minutes. There it is. Okay, I just had one more test. I wanted to see if that USB-C port worked, and it does look like it is okay, amazingly. So I've got a hard drive plugged into it here. And then on the server, I did a LS USB before I plugged it in. And these were the devices. Then I plugged it in an LS USB, and that Realtek adapter is found. So it looks like those two power MOSFETs that are there are just for, I think they're just for reverse polarity protection and for protecting against having two different power sources plugged in at the same time. Having, you know, like USB power delivery plugged into the USB-C port and 19 volts in the back. So I've lost the ability to, you know, do USB-C power delivery through the front. But neither one of those MOSFETs that I removed were necessary for just the regular data connection, not power connection for the USB-C. So I think that's it. I think the old BOSGAME is back to life again, all because of a little capacitor going out again on it. I don't know if they make high quality little baby capacitors like that, but if they make low quality ones, maybe BOSGAME, whoever their manufacturer is, they're not using great ones. Oh yeah, and as far as this camera, this thermal camera, I don't like it. It's too low of resolution. You know, I ended up desoldering something on the wrong side. Just because, you know, you just can't make out any detail with this thing. So I don't think it. I got to figure out what a higher resolution is, because I think this one looks about the same as the one that I had before, the really cheap one that I had before. And I think they were, you know, this one was no better. So got to look into that. But I'm just going to return this one, and we'll see if I if I need to purchase a thermal camera again in the future.